Hello, my name's Claire Horsburgh. I'm here today to talk to you about Oxford Primary Science with a focus on observation and experimentation in science. Um, at the end, there will be some time for some questions and answers, and I look forward to hearing your views then. So the aims for this session are to demonstrate the alignment between Oxford primary science books and the Pakistan single national curriculum, to focus on key themes, observation and experimentation, and the 3 C's, as I like to call them: connect, collaborate, and create. I also hope to provide you with some ideas and prompts for structuring science sessions within your teaching. So the single national curriculum just came in recently, and I was fortunate because I've been working on the science books for a number of years now, and we had done a complete revision and an update just before the new curriculum came through. So we had minor adjustments to make, some structural, to make sure that we had fully hit all of the aspects of the SNC. And these were first published as addendums, and then they will be incorporated into the text as we go forward. The SNC has a key focus on active hands-on learning, including self-direction from the students, movement away from dictation and teacher-led to student-focused, student-led, student initiative work. So this quote is taken from the single national curriculum: student-constructed learning as opposed to teacher-transmitted information. And this is really important as a motivator and as a key skill. Talking of skills, the single national curriculum also talks about higher order thinking skills. These are necessary for making connections with the wider world, for developing creativity, and for developing exploration. Children need to practice these skills. If it's just a teacher-led approach, they don't get to actually think, let alone develop the higher order thinking skills. So the books are carefully designed to, in a leveled way, take children through all of those necessary areas. But I'm going to talk to you a little bit more about how to use that. I would expect, as a teacher myself, and in your own practice, that we all use the curriculum document alongside the textbooks, just to make sure that we feel thoroughly confident with the language of it and our delivery of it. So the key ideas today are the focus in science on observation and experimentation, and our 3 C's: connect. I'd like to talk a little bit more about these 3 C's. So the idea of connecting scientific ideas, connecting with each other, and connecting with the wider world on in a science-based way, but also just making links between the different parts of what they're learning in the classroom and what's going on in the wider world. The idea of collaborate, working together. So we often say work in pairs or work in groups for a short amount of time. But if we can really increase that collaboration, where students are working together confidently, and where the teachers are working with the students really confidently, then we develop a better practice. The final C is create, and create is key to higher order thinking skills. You have to be able to come up with an idea and put it into practice, and it links back to the idea of observation and experimentation, to get some inspiration from around and about, and to have a go at things, making things, doing things in a creative manner in order to develop science knowledge. So that's very generally an introduction to those key things that we're going to talk about today. So first things first, if we want our children in our classrooms to do these things, we need to do them. So we have to be creative. And you need to think, what can you do to increase creativity in the classroom? You need to ask yourself that question and think about variety, because if students are subject to the same thing over and over again, they fall into the routine of it becomes dull. So you need to vary the structure of your lessons. You need to vary the types of tasks that they are given within each lesson or time period. And you need to vary the content of those lessons. So why do we need to do this? Why do we need to have variety? Why can't we just start on page 1 of the textbook and work through? Well, the key thing is engagement. If children are not engaged, if they're not stimulated, then they're not going to learn. And similarly, being a variety prompts this creative thinking. There's not a prediction, therefore they're guessing, therefore they're engaged, and they're making connections. Variety also develops risk-taking, because students know that the things will change, that there will be opportunities to do different things, and they will seize those because they won't have a predictable time where, once every 3 weeks they do an experiment. It could be any lesson, and that kind of variety really helps with all of those things. So how do we do this? How do we ensure that our classrooms are creative environments? Well, one is pre-planning, and under pre-planning comes preparation and preparing space. A classroom, a science area, a science classroom, part of the a general purpose classroom needs to be dedicated to making science visible, making science part of everyday life. And the pre-planning for the year ahead is looking at the textbook, seeing what's in there, and making sure that at key points you have timetable time where you can use that classroom space and create visible displays and signposting for students to use. Also, your own confidence. So the textbook is there for you as a tool, the textbook is there for the students as a tool, but there's a whole world out there. There's the curriculum itself, which is worth dipping into and looking at time and again, just so that you feel really confident with the matching between the textbook and the curriculum. And confidence through preparation, through planning, through making sure that you understand what you're going to cover, that you're not just going to use the textbook and follow it, but that you're going to have a plan that you have prepared, and that foundation will give you confidence. Your curiosity, you need to model curiosity for the students to be able to replicate that. So they're watching you, they're listening to you, they're learning from you, not just the content of what you're delivering, but how you are. So if you model curiosity, if you model stopping, thinking, asking a question, making a connection elsewhere, then they will pick up on that and they will do that too. There's also the aspect of differentiation. If you haven't planned how you're going to split something up, how you're going to group the children, how you're going to divide the tasks up, then on the spot you might make the wrong decisions. So it's really worth planning in who's going to be doing what and how much of it and how much support they're going to have and who they're going to work with. Your high flyers will be fine with anything. The ones you've got to watch out for are the ones who are perhaps struggling or have certain issues, and they need to be brought in and also encouraged. And this planning, organising your classroom, both visually and lesson by lesson, is really important part of that differentiation. There's a key focus that you need to have on what are they learning rather than what are they doing. So we can fall into the trap of thinking they'll do this, then they'll do this, then they'll do this, they'll do this activity from the textbook, etc. And that isn't focused on what are they learning. So we're going to talk a little bit more about that as we go on. And finally, in order to be creative, we need this time to reflect, to think, what did I do, what worked, and what action can I take? So lastly, I'll talk to you a little bit more about that and see if we can put that into place for today and as an action weekly when we are teaching. So we hear a couple of ideas using book 4, part 3, which is focused on materials and matter. Each unit in the book should be roughly a week's worth of work. So if you started on page 1 and you worked through unit 1, you could maybe whiz through it very quickly with a able children with no difficulties. But would they really be learning? I would say some of it will go in, but as you know, just listening, just using one method, things aren't going to stick. And what we're interested in is really developing understanding, scientific concepts and practices and knowledge. So these 2 examples. One is in your planning. So before you begin part 3 of book 4, you would go through it. You list the key objectives and they're neatly placed right at the top. You've got what they've already should have covered in the previous year and what they're going to learn in that particular unit. And you need to make sure that you're really clear. That's what you're going to try and convey to them, that you would like them to be able to explain those things to you or describe them to you or identify certain things and be able to apply certain things as well. So once you've done that, you need to read through the material and list the resources and make sure that they are collected together. Most subjects in primary are resource heavy, and this doesn't mean that you need to spend a lot of money or spend a long time on them. Again, a creative approach. Use what you have, use what your school helps you to have, and don't worry if you don't have something. Think of a way around it. Use the internet for ideas too, to supplement if you want to replace things. So in part 3, materials and matter, if you scan through, it talks about substances to heat, substances to mix, substances to separate, filters that are needed. It mentions candles, oil, a bicycle pump, magnets, face masks and containers. And if you collect together these things, if your school has lots of supplies, fantastic. If your school does not have lots of supplies, then household ingredients, salt, sugar, water, maybe some coffee granules, that kind of thing will be sufficient as substances. You might want, in a moment, I'll talk about some other ways to access it, but you might want to take in eggs, a frying pan, and a little burner, if you can. A cloth, strainer, filter paper, all those things. And if they're ready to hand and they're there for the entire time that you're doing part 3, so a couple of weeks, then you can dig into that box at any point and encourage the students to use those materials too. The next thing to do in your planning is to list the key vocabulary and think about printing this out if you can with images that you've collected or that you've drawn if you're artistic, and created a display so that the students can see the vocabulary, they can access that language, that it's not hidden from them, they can use it just like all the resources. And try to be creative with that. You can put some images into PowerPoint slides if you use PowerPoint or on another presentation device, or you can stick them up on the wall and make links to the wider world. So this is about materials and matter. We're talking about solids, liquids, gases, and images of different types of solids, liquids, and gases. Links, cross-curricular links to other topics. If you're talking about volcanoes, for example, what is lava, what is rock, what is the smoke coming out the top. Make those links and make them clear. Use labeling, use the visual part of your classroom. So with that kind of planning and preparation, you should feel fairly confident to then plan your way through the lessons that you're going to deliver. So that is a matter of dividing up the time and having a clear structure to your lessons and varying that structure so that things remain interesting and engaging for the students. And a second example of how to tackle this part 3, materials and matter, would be perhaps maybe start with some cookery, because it's creating a link between a wider world issue, a factor, and the classroom practice. So if you can't boil an egg or fry an egg in the classroom, you can find a YouTube link to somebody else doing that and show that. That would be fine. You could use images, or you could keep it really simple. You could get some uncooked rice, some mustard seed, some grains of salt, some flour, and sieves, and you could let children have a little mixture of each and tell them to separate it. You want them to be using the equipment that you've gathered. You want them to begin with experimentation. You want them to look and observe and question what it is that they're doing. Then when you go to the textbook and you talk about what's in there and you do the activities, they've got concrete examples. They've got practice at looking at specific things that they've worked through, and they will be able to apply that and make those connections. So as you can see, we're talking about you being creative, and we're talking about you planning, but if you do change your approaches and you do apply kind of different ways of doing things, you will also be helping them to make connections. Okay, so next I'm going to show you an example of a student who has been really creative with a bit of experimentation, and then I'll talk to you about what they've done. So in this video, the student has gone home and worked on a project, and they have accounted for materials they've used, they've brought in the simple machines that they've used in doing it. And obviously not every child is going to have access to this kind of equipment, but within your classroom, you can also have this same setup. So if you were looking at forces, it's much more creative, and it's going to form many more connections in their brains if you get them to have a go at using materials and making something. And you can see in that example, they used a stool and they used cardboard and they used glue tack, really, and tape, and they're experimenting and they're practicing. So it's vital that you get away from at the beginning of the textbook and working through, but that you do that preparation, you are confident about what's in there, and you mix it up a little bit so that they can go home, they can look at the textbook again if they need to, if they want to revise. But the thing that they have got from the lesson and the thing that they have got from your teaching is inspiration. They've got confidence, they are happy to try something, to give it a go, and then they know that they need to think about what they're using, they need to record what they find, and that they feel confident to share with you their experimentation, their observations. And it's the same with all the topics in the science books. You need to engage them practically and actively first, and then you can feed in the knowledge, and then they will make the connections and they will make progress. So finally, what I want to talk to you about is reflection. So in order to deliver the 3 C's, and in order to have effective science lessons focused around observation and experimentation, what you need to develop as your practice, if you don't do it already, and what you need to encourage your students to develop, is a reflective practice. So this needs to be positive. For today, I would like you to think about what we've covered very briefly in this time, and think about what you do well, and think about, following today's session, what will you try to change or try out or do differently to increase your focus on helping the students to be creative, to make connections, and to collaborate. While you reflect on that, I'll just talk about this more generally. So when we ask students to go, we take them on a field trip to look at a tree and to record the tree, taking photographs, drawing, collecting samples of leaves, investigating the bark for its structure, trying to look at any cut pieces to see the rings within them, those kinds of practical things. If when we're doing that, we take lots of records and then we go back into the classroom and we make time for, what did we see? What did we experience? What did we record? Then you are encouraging this reflective practice. And at the end of a project, you can ask them to even reflect on, what have I learnt? What did I do well? What can I improve on? So to go back to us here today, in your science practice, you'll have lots of things that you do really well, I'm sure. You know your classes, you know your curriculum, and following today's session, if you just apply one of the things that I've talked about, that would be really good. Even if you are someone who does vary your practice regularly, it's worth just trying something someone else has suggested, just to keep yourself engaged and curious and interested. And finally, to make us accountable, reflection is no good if we just reflect and think, oh, that went well, that didn't go well. That changes nothing. Reflection is only useful when we create an action to improve on something. So it would be worth buddying up with a colleague, another class teacher, or a colleague in a different school, or somebody online, and share with them some of the things about what you've learnt and this reflective process. And when you are in your classroom setting, if at the end of each week you think, what went well? And following this week, what will I try that's different? Or what will I change? Or what will I do differently? With that focus on those three C's, then each week you can set yourself a little goal for something just to adapt and change, and keep that reflective process going to keep your teaching fresh and focused, and make sure that you keep reminding yourself to bring experimentation and observation to the forefront. Okay, I know that's very quick tour in the time that we've got. Thank you very much, and I look forward to talking to you further in a short while.